Hi, this is Jason Baker, and welcome back to our lecture. In the previous lecture segment, I showed you how you can build a Docker image. You build a Docker image by starting with an existing base image, launching a container, making modifications to the container. When you make those modifications, you're essentially adding a new layer, and then you can stop the container and create a new image. And that new image contains the layers from the base image, and it also then contains the layer of changes that you made to your container. Well, building Docker images this way, building images by hand is sort of labor intensive, and it's also error prone. And of course, like most things, there's a way to automate this process, and we can automate it by using a Docker file. A Docker file essentially is a code file which serves as a recipe for building Docker images. You can uh, type in a series of commands into the Docker file. It's a text file, and then you can create a Docker image build using the Docker file. And what Docker will do is it will step through the commands in the Docker file, almost like a shell script, and it will then build out a Docker image. When you use a Docker file, you can use the Docker build command, and the syntax is to run Docker build -t and then provide the image name that you're building, and then you would provide a build context. So in this case, there's just a period for the build context, meaning that essentially you're telling Docker where it should find the Docker file. And this command is being run in the same directory as the Docker file, so we can just use the period character as the context. Let's go ahead and just create a Docker file. I'm going to use VI to create a Docker file, and I will copy in these statements from the Docker file. So in my Docker file, I'm going to be creating a new image. I'm going to use the Ubuntu image as my base image. And then I'm going to run a couple shell script commands. I'm going to do an apt-get update, and then I'm going to install the Figlet software package. So this Docker file is going to create essentially the same image that I just created manually. Let's go ahead and build it. So we'll do a Docker build. We're going to tag this image as Figlet2, and we'll just use the local directory as the build context. And so we run this command, and you can see that now Docker is gone out and it's fetching the layers of the base image, and it is running these commands automatically. And now it has successfully built a new image. If I do Docker images, then you'll see there's now a Figlet2 image. If I do a Docker run Figlet2 bash, I'm going to run it interactively. So Docker run interactively Figlet2 bash. Then I can do like Figlet and give it a string to output, and there we go. So there's just proof that we are able to launch a new container using the new image that we built using our Docker file, and we can successfully run that Figlet command. So in practice, anytime we build a Docker image, we're typically using a Docker file to do it. And Like other infrastructure as code practices, we can take that Docker file and we can check it into our Git repository so that it's properly versioned. We can also use the Docker file in part of a software pipeline and something like Jenkins to automate the building of software images anytime somebody makes a change to the Git repository where the Docker file is located. So um, when you, if I were to try to run this build command again, let me go ahead and do that. I'm going to run that build command again. If I run the command again, you see that it builds the image really, really quickly. Essentially because what happens when I build an image is it's Docker is taking each of those image layers and it's caching those layers. If I go to build an image again, then Docker will look to see if those image layers have changed. If the image layer hasn't changed, then it doesn't even bother to try to build the layer. It just pulls the layer from the existing cache. And this is what allows the build process to happen very, very quickly because it can leverage previously cached build layers. If I wanted to, I could reforce a build and I could pass in the no cache argument. And what that tells Docker is don't bother to look at the cache, and it should try to rebuild each layer from scratch, essentially. So I can override that caching mechanism. If I want to see the layers in an image, I can select my image. So I can do like a Docker history Figlet 2. And this will show me the different layers within my image. You can see like here's a layer of the image that was used to store just the Figlet package. Um, so that's how you can see the different layers that make up a particular image. So let's dissect the Docker file a little bit and look at some of the commands that you can include within a Docker file. Well, the Docker file begins with a command with the from command, and that has to be the very first instruction within the Docker file. You can put comments in a Docker file. The comments begin with the # character. Uh, but the first command within a Docker file must be the from command. And the from command defines the base image that Docker will use when building out the new container image. You saw that I used from Ubuntu, which is using one of the official images from the Docker repo. Um, and so I need to specify a base image using that from command. I can use the label command within the Docker file to create metadata key value pairs. And within these key value pairs, I can put whatever information I want to. It's common to specify a maintainer for a Docker file. You could specify a version for the Docker file. You could specify like the name of the organization, which is copyrighted the Docker file. You can put anything you want in there. So labels are is just metadata you can add to a Docker image. This CMD command specifies a default command to run when a container is started with that image. So when you start up an image, and when you start up a container using an image, you can specify a command that needs to be run. You can specify that at the command line. But in many cases, you're not specifying a startup command. So you can specify within the image itself, you can specify the default command that should be used when that container starts up. So what would a default command be? Well, you might create a container that has an Nginx web server in it, and the startup command could be the command that actually is used to start the Nginx web service within the container. So usually the command is the bootstrapping command, the startup command for whatever service you're running within the container. Here's an example Dockerfile where we're specifying Ubuntu as the base image. We're installing the Figlet software, and we're telling Docker that we want it to run the Figlet command and output the word hello. So if I let's go ahead and we'll create a new Docker file, or we'll modify our Docker file and add these commands and see what goes on, what happens. So now we're going to build a new image. I'm going to call it Figlet 3. We'll go ahead and build it here. And so we have Docker images. So now you see there's a Figlet 3 image. I'm going to just run that. I'm going to run a container using that image. So Docker run Figlet 3. And note that I'm not running interactive mode. I'm not providing any sort of command to run within the container. So now I've run a container using that image, and when I launch that container, it will automatically run the default command that's specified in the in the actual image build, and which was to in script format print out the word hello. So the command defines the command defines a default command to run in the container if no command is specified on the command line. So okay, so keep that in mind. If you don't specify when you run a container, if you don't specify a command to run within the container, then the container will run the default command, which is specified using the command uh, argument. There's also another way to run commands, which is sort of similar, and that's called the entry point. The difference is that when you specify an entry point, the entry point command is always run every single time the container is launched, no matter whether you specify a command when you're running the container at runtime or not. So the entry point command is always run on the server. You can use the copy command in the Docker file to copy files from the build context directory into the actual container image. So this is a way you can copy files from your host system into the container image. Why would you want to do that? Well, we do that all the time because you might, have source code for an application and you need to copy that source code into a container. And when you're copying that, it's copying it from the build context. Well, what's the build context? Well, if I when I run the build command, the build context is specified by this last argument, which in this case is just the period character, meaning that the current directory that I'm working in is the build context. And that's something that you have to keep in mind. If you're trying to copy files, you're copying those files relative to the build context. Let's go ahead and we'll create a file. And this is going to be just a little C application. We'll call it, let's see, what do I call it? Hello.c. So I'm going to create a file called hello.c. And it's got this, it's just a little hello world application written in C. So I'm going to save that file. Again, it's in my current working directory. It's right alongside the Dockerfile. I'm going to modify that Dockerfile, and I'm going to copy in these new Dockerfile commands. And so let's step through these commands. We're going to build a new image based off of the Ubuntu image. We're going to run apt-get update. We're going to run apt-get install. So these are just shell commands. I'll talk about the run command here in a minute, but run command is basically just running shell commands. Then I'm going to copy the hello.c file from my local build context into the root directory on the container. Then I'm going to run a make command. I'm going to compile that little application. And when somebody runs this container, I want the container to run the command hello, which is going to be that compiled binary. Let's go ahead and try this out. So we do docker build -t, and we're just going to call this one hello, and that's the name of our image, and we're going to use our local build context. So now it's going out and it's pulled down that image, installed the compiler right now, the compiler packages, and then it will compile my application, and it's successfully put and built a new image. So if we look at Docker images, there's my new hello image. And let's go ahead and run a container using this image. So we do docker run hello. And you see that it outputs hello world. That was the app, that little binary C application that I built, and that is part of the container. So that's how we can use the copy command to copy source code into a container. We can compile it, build our software application in the container, and then we can configure the image so that when we launch a new container using that image, it will automatically then run the application which was built. The work dir command sets the working directory within the container. So again, think of the work dir command as being sort of like a change directory command. If you're running shell commands in a container during the build process, those commands are going to be run relative to, or they're going to be run within some current working directory in that container. And you can change that working directory just simply by using the work dir command. The env command sets environment variables within the container. There's two ways you can specify. You can use env and then provide a key value pair, where we have the key equals some value, or you can just say env key name and then a value name, which is a string following the key name. And those environment variables then are available to an application service running within the container. You can also specify environments. You can dynamically inject them into the container at runtime as well by passing in the dash dash env argument. The expose command basically informs Docker that the container is going to be exposing a network port. And I'll be talking about networking in more detail in the next lecture segment. But you might have something like a web server that's running within the container. And what you'll find is that, or learn, is that usually the container networking environment is completely isolated from the host. Think of it as its own little, networking partition. If you want to expose a service that's running in a container to the host or to the outside world, then you need to explicitly expose one or more networking ports. For example, if you were running an Nginx web server inside the container, then you would probably want to expose port 80 or maybe even port 443. Just because you have exposed the ports doesn't necessarily mean that the ports are going to be available. And you'll see why here in a little bit when I talk more about networking.